Hello and welcome to this episode of NEAH's events. Today we are with Nicolas Zimmermann from France, and we are going to talk about carbon capture, utilization, and storage, or often known as carbon capture, utilization, and sequestration. Um, it has its own place in our net zero and sustainability goal. uh, Nicholas here started his startup called Carbonway in France not too long back, just this year. And today we want to know more about Carbonway, what is a startup's role in CCUS, and overall, what is CCUS is about and its role in net zero. So welcome, Nicholas, to this episode.
Thank you.
Let's just start with your background. Why don't you introduce to our audience about your background and about Carbonway?
Sure. So first, thank you for having me. So my background is civil engineering. So I studied civil engineering, and if I have to summarize my career, no, I worked for about 15 years, and I would use two keywords: so infrastructure and climate. So I developed a lot of different kind of large infrastructure, so transport, energy, a little bit of industry, and also climate adaptation infrastructure like coastal protection. Um, and on the other hand, the climate, because I was advising companies or governments on climate adaptation strategies. So after these 15 years, there was some kind of, let's say, growing frustration that maybe I was addressing not the cause of climate change, but the consequence. And I wanted to go back to mitigation because of that. So CCUS actually is, let's say, the intersection between my skill sets and my interests. And I thought, okay, that's probably what the world needs right now. It's at a good spot. We see the evolution. We will talk about it during this podcast. And so that's where I decided to put my energy. Yeah. So together with somebody else, with an associate, we founded the Carbonway. And so to continue about Carbonway, in a nutshell, what we want to do is we believe that carbon capture has reached a point where it will probably be democratized in the next 5 years, 5 to 10 years. And right now, carbon capture is mostly at pilot scale for very large companies who have the skill set and the resources to afford this kind of first mover project. But given the need that we have for carbon capture, and we will talk about this during the podcast, we think that within 5 years, probably it will be needed for also the smaller scale companies, so small to medium emitters, which maybe do not have as much resources or skills to do that. So that is where our positioning is. So we hope to be able to democratize carbon capture as independent providers. So we're not a technology provider. That's very important to help them decarbonize fully. So in a nutshell, about Carbonway.
Okay, so this is really interesting because normally my understanding was that it's usually the large companies and the large corporations that are able to get into this domain um, for scale for one reason. And now that you bring an idea that even the smaller companies can actually take part in this journey, it's really interesting. So we should probably talk about it. But before we get into that part, let's cover some other basics first. So, I mean, I understand your motivation, but can you walk us through a little bit about what CCUS is and what are we going to be talking about today?
Yeah, absolutely. So I have a few slides, so maybe I can put them on screen.
Yeah, absolutely.
All right. Just a moment. Share screen. All right. Just confirm, please, that you see the screen.
Yeah, I do.
All right. Um, so what is carbon capture? Just a moment. Move. Yeah. Okay, I still have two slides about Carbonway. We already talked about it, but basically what we do is we believe that deep decarbonization, so full decarbonization is possible. And what we want to do is help specifically industry, so those hard to abate emitters, to go to net zero. and carbon capture is one of these solutions. We will see it's not the only one. So we do consulting, team reinforcement, or project development. Yeah, small to medium emitters. I will skip that because that's not the topic of the day. But so what is carbon capture and why is it needed? I think that was your question, right? That's probably the right slide.
Yes.
Yeah, okay. So when we talk about carbon capture, there are three kind of things we can think about. First is industrial capture, second is natural capture, and third is direct air capture. And they don't have really the same characteristics or purpose, right? Industrial capture basically is like you have those huge industrial plants. They have a chimney. They emit CO2 into the atmosphere, and they are the primary cause of global warming right now. Of course, together with other sources of emissions like transport and so forth. So when we talk about industrial capture, it's about addressing the root cause of global warming, and especially the process emissions, because it's not only about burning fuel, it's also because some of the processes that are used in industry, for example, in cement industry, by themselves, they produce CO2. So we have the fuel emissions and we have the process emission. That's very important. We have natural capture. Natural capture, basically, it's a tree growing, right? When it grows, it captures carbon within its leaves. And that is something that we can also leverage through reforestation, for example, but also everything related to biofuels or bioenergy with carbon capture and storage. Because the idea is that even if you are going to use the fuel later and burn it and some CO2 is going to be emitted, because this CO2 has been captured during the growth of the plant, it's net zero. And so if you capture it during the growth, and then in addition, you don't even emit it, but you capture it after emission, then you are even net negative. And the thing is that it will not be sufficient to go to net zero. Actually, everybody talks about net zero right now. A few talk about net negative, but eventually we will need to be net negative as a society as a whole. And so natural capture is very important for a net negative future. And then we have direct air capture, which is also for a net negative future. What do? We suck the CO2 out of the atmosphere, and again, we store it somewhere so that we fundamentally decrease the CO2 concentration in the atmosphere.
Add one quick thing. You mentioned about net negative here, and if I understand you correctly, we need to push towards net negative because the climate change effect that we see today is not because of the carbon dioxide we release today. It's a cumulative effect that takes decades to centuries. So whatever we are releasing, it will show effect in 50 to 100 years. So today we need to push towards net negative so that we get an accelerated effect of bringing the whole temperature rise within a limit. Okay, all right. Just wanted to clarify that. So yeah, please.
Okay, so this is maybe a little bit technical. It's a graph about the emission reduction trajectory that is forecast by the IEA. It's a little bit outdated from 2020, but the message I want to pass across with this graph is that it needs to move very fast. So we need to decrease by 40 gigaton more or less, which is the total global emission. Global emissions are about 40 gigaton per year currently. And we need to go down to something close to 0 gigaton per year or below zero, as we just said, right? Now, there are two things we can see on that one. The first one is that you see different colors. Basically, they correspond to different kind of solutions that we can use to decrease emissions, right? And the key message here, you see the orange is CCUS. So CCUS is expected to play a very important role in the future in total decarbonization. But it's not the only one, right? It's a sum of many options, and every option will have its role to play. And the second message is that even if we start today, let's say we are close to the zero here, because especially when we talk about industrial capture or industrial emissions, these assets, they have a very long lifetime. Development cycles are very long. If we start thinking about it today, we will only operate in 2030, right? And that is a huge issue because, for example, the European target of the Fit for 55 package states that by 2030, we should have reduced our emission in the EU by 55% compared to 1990. But if we go to the regulated market for those industrial players we're actually talking about, it's minus 62% compared to 2005. So it's basically minus 50% compared to today in the next 5 years. It is gigantic. It's just huge. Okay. And we are probably not on track. So that's something very important to frame a bit the discussion we're going to have.
So I have a couple of questions.
Sure.
So you mentioned that if we start talking about it today, then we have an operational facility 2030, let's say. Why is there's such a big gap? Like, is it because of the infrastructure size? Uh, like, why do we need, let's say, 6 to 7 years before something gets functional?
Yeah. It's because infrastructure development, and we're not talking about your backyard, a house, or a small road. Large infrastructure development takes a very long time. First, because engineering is not easy. So let's say engineering alone, we probably have 1 to 2 years easily at minimum. And then we also need to have permits because it's highly regulated. We are talking about pollutants and stuff like that. So again, permitting is minimum 1 year, usually more than that, so maybe 2 years. And then you have construction, which is again 1 to 3 years, depending on the size of the facility. And when you add that all up, actually in CCS, anticipating a little bit about the carbon capture thing, historically, on average, a CCS project needed 6.5 years to be developed. Now, of course, everybody hopes to reduce that because it's going to be easier with time. Maybe people get used to the permitting process and stuff like that. But it's never going to reduce below 3 to 4 years. That's really the absolute minimum that we can do in the future.
And so I see that this is a reference from the IEA. So by most countries in Europe, US, let's say the developed part of the world, they have their 2050 net zero goal. India, China, they have all promised to be in that state as well by 2070. So, I mean, most part of the world is probably trying to get to net zero by 2070. But what it clearly shows that the CCUS has a substantial role to play in that. So what does that mean? Does it mean that, I mean, we also see a huge drive towards moving to non-fossil fuel energy sources. And the fact that we know about 75% of the emissions is coming from the energy sector. So what does it really mean that there are certain sectors that we cannot really replace uh, fossil fuels, or does it mean that we will probably be a bit more complacent in trying to switch out?
It's because mostly because it's not easy to replace. It's easy to say on paper, let's electrify everything and get rid of fossil fuel, but in practice, it doesn't work that way. So, for example, in transport, that's already great. We are shifting to EVs. That's going very well. The whole industry is changing. For renewables, it's great as well. But renewables have an issue. It's intermittent. So that means that during the day, we can produce a lot of solar, for example, and at night we don't, which means, okay, we can compensate it with batteries, but again, there are other kind of issues. Just to say, every option has its own advantages and issues. And when we talk about industry, for example, a coal plant, uh, we let's say there are activities for which we just need the strong power that fossil fuels bring and that renewables cannot bring easily. We could theoretically electrify a boiler, for example, something like that. But if we need to attain like 1,500 degrees Celsius for a given, like, I don't know, calcination process in cement or to melt steel, this kind of heat is very hard to achieve with electricity. And then we need to think about other options, right? So maybe it's hydrogen. But again, hydrogen has other issues as well. And so carbon capture is a way to deal with some of the situations that, especially in industry, that cannot easily be achieved with electricity.
Yeah, so you were showing another slide, I guess.
So we can continue if you want, yeah.
Yeah.
So it's to illustrate a little bit what we just said also about why carbon capture. Another point is that because we have already plants which are there, right? We could decide to close them, but closing a plant also, it's a financial loss for the investor, but it's also a loss of jobs behind for people who were there. So money and jobs, it's related. Unfortunately, it's like that, right? So when we have a new plant, we cannot just say, let's stop it and we will replace it by solar. So, for example, on the graph on the right here, you can see that this is the average age of a coal plant in the world. So, for example, the first column is the number of, or let's say the installed capacity in gigawatt of coal plants which have an age of less than 10 years. Now, when you know that a coal plant typically has a lifetime of at least 30 years, now all these plants which are in developing economies, especially in China, for example, they were just built, basically, on the time scale of the lifetime of a coal plant. They were just built, so we can't just close them. For example, for a plant which has been built 5 years ago, most likely the only solution is going to be a CCS, because we're not going to close it that easily, otherwise we kill jobs. And then in advanced economies, of course, we built our plants a bit earlier, so they are older, so it's easier to phase them out. And you can see in the news, right, just last week, there were a few major announcements on closure of coal plants, but they were only in advanced economies. It was a G7. And so for the other ones, especially developing economies, carbon capture is expected to play an important role.
So just to clarify, when you talk about these numbers in this slide or the previous slide, it is specifically about the carbon that is being actually captured from facilities, active facilities. It is not the one that is captured by the trees, or it is not about the direct air capture. Am I correct on that?
So on the previous graph, this is from the IEA. These are emission reduction we need to achieve. So because we emit every year 40 gigatons CO2, this is what we emit. It has nothing to do with trees or whatever. These are our cars or our factories, right? On this one, this graph is about the energy. It's not about emission. It's about the energy production capacity of coal plants in the world today and their age. And so, of course, there is a link between energy and emissions. But again, these are facilities and it's not natural emissions. Yes, absolutely.
So moving on, could you talk about, let's talk about CCUS itself. So it stands for carbon capture, utilization, and storage. So as we understand, there are two parts to it. One is utilizing it, and the other one is like storing it for good. So could you talk about that a bit?
Yes, so we go a little bit further. So how does it work and what do we do with the CO2, basically, right? So maybe one first message is that carbon capture is not new, right? We talk about it now, it's more trendy, but actually carbon capture facilities have been in operation since the late 70s or early 80s. The very first project, I have it on another slide, was in 1978, I believe, in the US. Most carbon capture facilities in the world, they are what we call amine-based carbon capture facility. When you look at it, basically it's two columns like this, and you would put the gas from your chimney coming into one of the columns at the bottom, and at the top you feed in some chemical product which is called a solvent, and the CO2 of the flue of the chimney will be absorbed by the chemical, and the flue gas without the CO2 will go out, and we will get rid of it. And then we go to the second column. So our solvent, which now has a CO2, goes in the second column. And by heating it, the CO2 is going to be released again. And now we have some kind of purified, let's say, CO2. That is just a basic principle of how carbon capture works. And because now we have a concentrated flux of CO2, plus minus some other things, we still need to clean it a little bit and then compress it for transport and other technical details. But then let's call it pure CO2 that we can store or use and decide what we do with it. There are many other kind of technologies which are changing to reduce the cost, make it more effective. Then what do we do? So usually, so we need to transport it. So let's say, I don't know, let's take one of these facilities here. We have a chimney. We transport it either by pipeline, by ship, by truck, in many ways, by train. And we bring it to a CO2 injection site here. I don't know if you see my mouse.
Yeah, I do.
Yeah, okay. So you bring it to a CO2 injection site, and we will pump it back into the ground very, very deep in usually depleted oil fields. It was a place which previously already had oil or gas, and we put it back inside. And because it's so deep and we manage carefully maybe the cracks in the rock and stuff like that, we are sure it will not go out. But we can also do something more useful with it, which is to reuse the CO2. And there are plenty of industries we can reuse the CO2. And let's bring it here. We can do, for example, what we call green fuels, for example, for planes, for ships. We can do other chemical compounds for the chemical industry. We can use the CO2 and mineralize it. Basically, we turn the CO2 into stone, and with those stones, we can, for example, build roads or buildings. Or we can use it in the food industry, so in greenhouses, and the plants grow better because they breathe CO2. We can put it in the drinks, the Coca-Cola you're going to drink, for example. Or historically that was the only way we used it, we put it in enhanced oil recovery. That means we pump it back into the ground, but push the oil so that we pump more oil out of the ground. So that's not very green, right? So you can see there are many ways we can actually use CO2. That's a good news.
So you talked about enhanced oil recovery. So my question is, when we use the CO2 for EOR, is it still being counted as sequestration in terms of how much we want to reduce, or it doesn't matter?
That's a good question. So normally the CO2, when it's used for enhanced oil recovery, historically nobody cared whether it goes out or not. We just assume it stays in the ground, but we don't even. I'm not sure. I will need to ask some expert on that, but I'm not even sure that we would check the CO2 doesn't leak and go back outside eventually, because that was not the primary purpose. Historically, the purpose was to pump more oil, right? So of course, if you want to sequester CO2 to reduce emissions, I mean, enhanced oil recovery is just not going to be acceptable, because it's just in total contradiction with what the primary purpose of storing CO2. So, it's also the more bankable, so that is why historically it has been done. It's more profitable.
Okay, so one question is this CO2 storage sites. Are these any oil and gas reservoirs, or there are specific sites that are preferred? Can you say something comment on this, like anything about the sites?
So maybe I will start by showing a bit where they are. So there are several places we can do it. So we have those depleted oil and gas reservoir we just talked about, but we also have what we call saline aquifers, which are like underground water reservoir. And so, for example, on a map of Europe or of the US here, everything in gray are zones where we could potentially store CO2 because these are saline aquifers. Or storage zones. Also, probably the depleted oil and gas fields are probably inside this as well. And then I'll use that opportunity also to say where we currently stand with storage opportunities. So it's easier also from a public acceptance point of view to store CO2 far from populated area. And that is why currently most storage projects, which are the red dots here you can see on these maps, the planned storage projects, they are at sea, because at sea there is less risk of public opposition to the project, and then that it gets cancelled and so forth.
But are there any other risks, like potential health risks, or because for example certain gases are toxic, but CO2 Absolutely. Is not that toxic? But are there any other health risks?
So CO2 is a toxic gas. It's not good for health, at least for us. But the toxicity level is much lower than many other industrial gases we can have. So basically, the main issue of CO2 is just that when there's too much of it, we cannot breathe anymore. Right? It's just that, right? So the main risk is that if the concentration of CO2 increases too much, then we are subject to asphyxia. And there are guidelines about which concentration leads to which effect to health. It's a bit technical. But there are other risks, and the biggest risk is mostly like when we fund, because states are putting quite a lot of help for these projects, right? So when we fund a project to try to sequester CO2, we also want to have some kind of guarantee that the CO2 stays there, right? And so that is in terms of risk. So of course it's a health risk, but mostly for storage, it's a risk like, is it going to stay there, right? And this is much less obvious already, because when you have a depleted oil reservoir, you have also changed the pressure within the reservoir, and that might have created a lot of cracks in the ground. So despite the fact that it's very deep, you're not sure that the CO2 is actually going to stay there. So depending on the characteristics of the geology, maybe the porosity, permeability, and a lot of other things, there are going to be surveys and then technical studies to make sure that the CO2 we inject will actually stay there. So is every place suitable? No. But we know, because historically we have done it already, we know with the proper survey studies and especially the monitoring afterwards, we know how to make sure it stays in place. And that is an important message. The message is, it's not dangerous. We know how to do it today.
So if there is a small diameter CO2 pipeline running through my neighborhood, should I be concerned about it?
Absolutely not. No. Normally, any project with which is industrial will be subject to permitting processes, and especially in developed countries, these processes are very strictly defined. You can't really play with it. I had to do this kind of processes in my work. You can't play with it. And actually, the risk, it's rather than your project gets cancelled because you couldn't really show like it's 200% secure, and then you don't get your permit. And also these pipelines, usually you would put them underground, like it's not in your backyard. They would drill and put it underneath, so you won't even see.
Okay, all right. So actually, a good point that you raised was about the characteristics of the reservoir itself, because if you don't know what are the cracks and fissures in the reservoir, so you don't know if the CO2 is staying in or not. Uh, and maybe it's better to make sure that it doesn't start affecting our water bodies that are for human and animal
Yes.
consumption. So okay, that's definitely a very good point. Um, so my next question is that, let's say that we need CCUS, and we know that uh, some of these projects are they can be beneficial, and we can have the implementation successfully and profitably. But who is really responsible to actually implement it? How does the implementation chain work?
So the main, let's call them the project sponsors, okay? So the project sponsors of CCS projects currently are mostly large multinational listed companies. They do that because they know it's the future. They have also seen those forecast studies. They know that the alternatives are there, but maybe are slightly less good. And they can afford to take the risk of implementing something for which there are still a lot of barriers to adoption that require significant capital, significant manpower, skills, and for which the outcome is not guaranteed yet. I mean, we're not talking about developing the 1,000th solar park in France, for example. We are talking about what we often call first of its kind project. Now, of course, there are a lot of red circles on these maps, but you have to realize that most of them are in development. Very few of them are actually already operational. So there is not so much experience right now from existing facilities to translate and be able to say to the investors to decide whether they will actually invest in it or not, to tell them, don't worry, it's fine, we know what we're doing. No, there is substantial risk. And this risk can only be carried by heavy project sponsors, those who have the skills to do it. But then, of course, you have other stakeholders inside, because you are talking about in the value chain who does what. And well, everybody has its own role to play, right? I mean, in order to have for example, a carbon storage project working, it means you need CO2 to store inside, right? You're not going to spend a billion, a few billions on a storage project if nobody wants to put the carbon inside. So that means that they have to work together with first movers of industry in industrial sectors who want to decarbonize. And also, then you will realize that maybe the regulations are not foreseen for carbon capture and storage because it's so new. And maybe CO2 is still treated as a waste and is not allowed to leave the country. So if you want to transport the CO2 from the Netherlands to the North Sea, you're crossing a border, and maybe the government is going to say no because the regulation doesn't allow it yet. So the government also has a big role to play. It has a role to play in making sure that these regulatory barriers are being removed. It has a role to play in making sure that it gives sufficient visibility for, let's say, the bankability of the project, for example. If the government says currently, don't worry, we have a regulated carbon market, you can count on the carbon price increasing and your project will be viable. But then in 10 years, it changes tack and says suddenly we are going to scrap that or we're going to reduce the carbon price. Then suddenly it's not viable anymore. So visibility for the government. And then, well, you have a lot of other slightly less important stakeholders, but we need to communicate about that, make sure there's growing awareness, that the population is not against it. You need industry bodies to promote that and so forth. And you need, of course, the startups, the technology providers to develop the new technologies, or companies like ours to promote and help the smaller ones who maybe don't want to think they are maybe not ready yet.
Okay, so if I understand you correctly, if I were a power plant, a thermal power plant, then effectively it is my responsibility, or it's the power plant that is going to actually implement the project or not, and the decision will depend on the power plant and its investors. Is that correct?
Yeah, that's
And
correct. And that's because each facility has the obligation to bring its emissions down to zero.
okay,
But
and of
let's say it will
course
be punished if it doesn't.
that is a regulatory measure, and typically they use some sort of economic levers to
Yes,
control these decisions. So the company ultimately calculates its profit and loss, and if it sees that it can implement a
absolutely.
project profitably, it will do it. Okay,
Yes.
so that's helpful. But then, um, if you could talk about the scale of this solution a little bit, like typically these red dots are these projects, like can you give a brief idea about what is the typical size of each of these projects?
So I think I have a few examples, but I will expand a bit on that.
Okay, go
Um,
ahead.
so facility, let's take Europe as an example because we have what we call the EU ETS data. So every facility in Europe, which is on the regulated carbon market, publicly declares its emissions. So we know exactly the distribution of emissions in Europe. And when we talk about a big facility, typically it's more than 1 million tons CO2 per year. That's a very big facility. It's a huge steel plant. It's a refinery or a power plant. And when we talk about a medium-sized facility, typically it's 100,000 tons per year. That would be maybe a glass factory, a sugar factory, on paper, things like that. And when we talk about small facilities, more like industrial furnaces, industrial boilers and things like this, it's more like 1,000 to 10,000 tons per year. It's very small. And the overwhelming majority of the facilities is between this 1,000 and 100,000 tons per year. That's maybe already 90% of all facilities between 1,000 and 100,000 tons per year. And between 100,000 tons per year and 1 million tons per year, maybe you have another 7 to 10%. And above 1 million per year, you only have a very few percent, maybe 3% of facilities in Europe, which are of that size. Storage, it's slightly different because you're not going to build 1 million different kind of storage facilities, and you also have bigger storage capacity in the ground. When we talk about oil and gas fields, usually it's quite big, right? So for storage, the cost is also much higher because typically the storage capacity is in the multi-million ton per year storage. And so here on this slide, there are a few examples for storage, not for, I think there's another slide on facilities. For storage, the one notable one was the Sleipner project in Norway. which stores 1 million tons per year, and that was operational since 1996. So you see, it's not new. And then maybe the highest profile one, storage project in development today, which is the most advanced, is the Northern Lights project in the North Sea, which is going to have 1.5 million ton per year storage capacity as of end of this year, I believe. And then they will expand it with another 3.7 million ton, which means total capacity of 5 million ton per year by 2026. But then we look bigger also because to compare, I believe total emissions in the regulated European market are more than 1 gigaton per year. So it's more than 1,000 million ton per year. And so we need bigger ones. And so you have, for example, the East Coast cluster in the UK currently in development. Eventually, not now, not in 2030, but eventually is expected to up to 23 million ton per year inside. And same for the Aramis project in the Netherlands. This is a storage, an intermediate storage project. So it's not like to the final destination, but they have also designed it for much bigger capacity. So that means that those industrial players also anticipating that the entire continent eventually a substantial number of facilities will use carbon capture as part of the solution. Not everything, but part of it.
Okay, so I have a question here related to this and to something that you already talked about. So, so it looks like it's quite clear that we do need CCUS to be a part of the net zero solution. We actually do have some experience, and it's very evident that we need larger projects as well. But you briefly mentioned that convincing the investors in many places has not been easy, but at the same time, this technology has been around since the 1970s with enhanced oil recovery. So, what makes it so challenging? Because it's not really a brand new technology. Its use is where like the use case is new. So, what makes investors wary of it?
Yeah, so you're touching upon the barriers to adoption. We are going to go through that. I have several
Okay.
slides on that.
Okay, so let's touch upon that later then.
Yeah,
So my other question is, um, you showed in the second slide, I think, like how much of the carbon that we are releasing today needs to be captured and will not be um, replaced by other sources of energy. But where do we stand today on that?
we are not on track. Let me check. I should have something like that. Yeah. Okay. So as of today, there are 40 CCUS projects operational for enhanced oil recovery. We talked about it. But unfortunately, in terms of capture of CO2, they have not always performed well, right? Because well, various issues. We're not going to enter into that. Here, again, for your previous question, we have a few examples of, let's call them large-scale facilities which are operational today. So again, in the million-ton range. But about the gap. Now, the gap is that currently in operation, we only have 45 million ton capture capacity in the world in 2022. And by 2030, we need 1 gigaton, so 1,000 million ton capture capacity. That's in 5 years. Now you can see on the graph here below that the gray is what is currently operational, and the rest is what is currently in development. So the pipeline of projects in development is much, much bigger than what is currently operational. But still, when you look at the pipeline in development in 2022, it's 400 million ton per year capture. And we said we need to reach 1,000 million ton per year by 2030. And also, among that, we are not certain that everything will receive its final investment decision. Maybe many of these will be cancelled. So this gives you a bit an idea of how far off we are from where we ideally need to be to follow the net zero scenario. We are very, very far from it today. It means that just to be able to reach the 1,000 million ton CO2 per year capture capacity by 2030, we will need today announced a new development of 600 million ton capture capacity today, and that not a single one of these projects fails in the middle. All of them become operational on time in 2030. So this is a very, very far-fetched goal. It's very unlikely we will actually meet it.
Okay. And on your right-hand side, I see an interesting fact that like most of the developments are in the emerging market.
Yeah.
And why is that?
So that ties back about what we said about coal plants. We said in developing world, the coal plants are very new, for example, and they will all need carbon capture because we can't just decommission them. They're too young to be decommissioned. In advanced economies, there is a little bit less need because the coal plants, for example, we can decommission them. So the need comes from industries and other, maybe the gas plant, which pollute a bit less. Yeah, and just the emerging market, you already have China in that in that big gray zone. You have India, a huge country as well, and they contribute significantly. Yes, so this is going to be a big challenge, especially because maybe they are lagging a little bit behind developed countries. There are great strides being made. For example, in India, they are going to, believe, implement some carbon market by 2026, which is pretty soon. Um, Basically, everything is moving pretty fast, so let's remain hopeful.
All right. Then, if I understand correctly, this capture is being done there and then sequestered locally, or is it being transported internationally as well?
You can transport it internationally, and it's probably going to happen in several cases. But you also have to keep in mind that transport is very expensive and it can make or break the project. And so if later we talk a little bit more about cost, you will see that the further you are, the less likely it is that actually it's going to be viable.
Okay. So going back to the earlier figure where we see a very few projects that are actually operational compared to what is required, and even the planned ones are nowhere close to what is required. So what, according to you, like are the greatest barriers? Why are we not getting there? Is it that we woke up too late and we are just starting, or are there some actual barriers to it?
Yeah, there are a lot of barriers. And to come back to your previous questions about why investors don't want to invest, maybe the first thing to say is that historically, they only invested in enhanced oil recovery for high concentration, for facilities where it's easy to capture the carbon. So you can capture it cheaply and you can use it to earn even more money. So it's profitable, right? But now we are changing the mindset entirely and we are trying to make something profitable where you actually based out of waste, right? Unless you utilize it and maybe you can sell your CO2 to some company who is going to use it for storage, it's a waste, right? You are not selling or making any products that somebody buys. The backability is solely based on how much less penalty you will pay because you pollute less. So it's based on the carbon price. And so
Okay.
if you go to the barriers, right, our interpretation is that there are 6 main barriers, right? So you have the offtake solution. That means, do you even know who is going to take your CO2? Maybe you are at a place where there is no storage, there is nobody who's going to use it, and then you have no solution. The second one is about technology. We said it's a mature technology, but only for one type of technology, and it's an expensive one. And now there are new ones which are cheaper, but which are also not proven. And when it's not proven, it makes investors wary. So you have to prove them that, or to convince them that the risk is limited. You have what we call the integration risk. And integration means that you have an existing facility, you want to basically expand your facility with a carbon capture plant, but maybe it's not that easy because, I don't know, you have no space to do it, or you are in the middle of the city and maybe you do have a few extra constraints for permitting, or you have no transport opportunity, and so forth. Then you have the bankability barrier that we talked about it already. Maybe it's not profitable. You have the regulation barrier. We also talked about this already. Maybe some of the issues are not resolved yet. And then you have the awareness and financing. So it touches upon like public acceptance, and financing is investor acceptance. But all these barriers, in our opinion, currently are falling, and they're falling pretty quickly. And that's why we think it's a good moment for carbon capture for the carbon capture industry. I don't know if you want me to go on with a few examples or not.
No, this is good. I mean, I just like had something in mind. So let's say I use the CO2 for enhanced oil recovery. So I'm actually spending some money to put the CO2 in the ground, and in return, I'm going to get certain barrels of oil addition to what I would have got, and that additional dollar that I'm earning has to offset my CO2 cost here that I spend. But in our case, where we are trying to actually do it purely for the environmental reason, that the whole economics now pivots on the carbon price now. Like if the carbon price is like the oil price now,
Yes,
so if the
absolutely.
carbon price is not good enough, then the solution doesn't work well for
Absolutely.
investors. Okay. All right. This is very clear. Now, talking about awareness. Why do you think, like, I would agree, I would think that most people will be quite aware of climate change and the challenges it has. A lot of people are facing it directly. Why do you think people are not aware of it, of carbon CCUS in
Yeah,
particular?
I think they are pretty much aware of climate change. I mean, depending on which country you're in, priorities are not the same between developed and developing countries. Um, but carbon capture specifically, that's already it's well, people hear more about renewables, for example, right? So renewables is already more awareness. Carbon capture, not everybody knows about it. So that's the first thing. And when they hear about carbon capture, sometimes they get the reaction like, "Why do you want to capture it? Just stop emitting," right? So they will tell you it's greenwashing. That's one of the common words you will hear about carbon capture. It has a very bad reputation. So awareness also means explaining why carbon capture is not greenwashing. Obviously, it needs to be done properly. If you do carbon capture to do enhanced oil recovery, that's greenwashing, right? But we need to build a little bit of awareness of why do we need carbon capture, what does it do, and show that there's no risk also. So yeah, on this part, there's awareness and capacity building too.
So if you could give us some examples on the regulatory scenario, like because the regulations are quite different from, let's say, Europe to North America to Asia. I mean, where do we stand? Which part of the world is most ahead in this race? If you could give us some idea.
Yeah, definitely. So there are people whose full-time job it is to look at all the regulation. So I know I'm a generalist, not an expert on that. But I can tell you for sure that regulations are more advanced in developed countries. That's for sure. The EU, the US are currently the two places where you have a much higher probability of making your CCS project a reality. Um, but these regulations, they are also being built quite quickly in developing countries as well. It's just that they are not at the same stage. And also, for example, concerning the carbon market, we just said that the viability of carbon capture depends on the carbon price, right? Carbon markets are also existing in many other countries, but they are not always either implemented yet, they're in the pipe, or they don't always have a carbon price which is high enough. For example, China, which has the highest number of coal plants in the world, they have a carbon market. They have a carbon market, but the carbon price is very low. It's very low, and so there is no incentive currently to develop that at a large scale. And that's why when we talk about regulation, it's also about what are the details of the regulation, and also, does it cover all pillars? Because maybe you have the carbon market, but you didn't sort out yet, for example, international transport of CO2, or maybe you didn't sort out yet the government subsidies that you need to kickstart those first mover projects, and so forth and so forth. So regulation is not like one law and I fix it. Regulation is a quite complex thing. It's also about permitting duration and things like that.
So this is probably the irony of life. It was clear that you need more of these projects in the developing market, um, but you have more advanced conditions in terms of market and technology in the developed part of the world. So I assume that there is a fair bit of cooperation between the two parts of the world in terms of technology transfer and knowledge transfer.
Well, I suppose so. NEAH is actually one of these companies um, um, active in that field, I suppose.
We are
I
trying
know
to
a
do our
few.
part.
Sorry.
We are trying to do our part.
All right. So yeah, I'm aware of a few colleagues who also contribute directly to that exchange through their work. Um, they are like associations. For example, the Alliance for Industrial Decarbonization of the IRENA, so in International Institute for Renewable Energy, which is open to all countries in the world, right? It has 170 members. So there are places where developing countries can join to share and exchange experience with developed countries. Yes, absolutely.
Okay. So changing the gears slightly, all these numbers that you showed me, these projects you've been talking about, the examples like thermal power plants or the steel industries, these are naturally, like these are the big industries and they're the natural industries of choice to do this carbon capture in a scalable and profitable way. Um, but what about the smaller industries? Because a large fraction of the economy is actually driven by the small scale industries as well, and they in aggregate do emit a lot.
Yes. Um, Maybe I will go back to a slide at the beginning. I want to reinforce a message here that we talk a lot about carbon capture, but actually it's not only about carbon capture. When we talk about full decarbonization, there are plenty of other solutions, and especially the smaller ones. They should look at the whole picture. Of course, if you are a cement plant and there are process emission which account for almost 2/3 of your emission, maybe you are not going to have another solution than carbon capture. But for other actors, well, obviously you start with energy efficiency. So to make your process more efficient, that you use less energy. Maybe you have some waste heat recovery system to be able again to reduce your energy use. Then you have to address your fuel emissions, and here it's not about carbon capture. It can also be about replacing your fuel. For example, maybe you're going to use hydrogen, which is quite expensive. That's the problem right now. Or you are going to use biofuels, which can be net zero, net negative, instead of your conventional gas. Or maybe you're going to electrify your process. So for example, this image is an example of an electric arc furnace in a steel plant. So you can melt steel with electricity. Then you have a process emission, that's the hard part. So obviously we talked about carbon capture, but even that, you can address process emissions by, for example, using recycling. So for example, in the in the glass industry, you can recycle your bottles or recycle your windshields and so forth to use it as feedstock to produce new glass. And the good thing is, for example, glasses, if you use pellets, it's called, so recycled glass inside your oven, not only are you going to create new glass by reducing emission, but also it's going to reduce your energy consumption. So everybody wins. So small companies, to come back to your question, I believe that they have to look at the whole picture. That's the first thing. And second thing is that, well, yeah, it's harder for them. So there are other, they have to deal with it in a different way. Maybe they're going to externalize a little bit more to get external help instead of doing it internally. That's, for example, why we are here at Carbonway. But they are also going to rely on other instruments. For example, often in European countries, you often have specific grants which are targeted at smaller companies. So you don't have the same tools to work with also. But I agree with you that the challenge is a little bit bigger also because the economies of scales are maybe not as big as you can have them elsewhere.
Okay. So I have a number of three questions in specific, going back to some things that we discussed already. Uh, Firstly, when talking about economics, how much does it actually cost to if to sequester a ton of CO2?
The cost depends very much on the facility. So it's not like you can say the cost is the same for facility A and B. They can be totally different. So it depends on the size, economies of scale, on the location, how far you are from the storage site, on the CO2 stream composition. So what comes out of your chimney, how much CO2 is there actually inside? If there's more CO2 coming out of your chimney as a proportion, it's going to be easier to capture it. And then you have the integration ease. Maybe it's not easy to integrate. It's going to cost you more money just to modify your plan. For example, there are some industries which have a lot of tiny chimneys with a lot of emissions, while other industries where you only have one big one. It's easier, of course, to capture it from one single chimney than from a lot of point sources. And about costs, so capture cost, because of all these factors, can range between 20 and maybe $120 per ton, order of magnitude, depending on industry and so forth. For example, if you're in the natural gas processing or ammonia sector, it's going to be much cheaper than if you are in the cement or the steel industry or power generation. And then direct air capture, just as comparison, that's extremely expensive. So that's also why we're not talking about it right now. It's not a solution for the problem of today, but it will be needed in the future.
Okay.
And that's only capture. And then you have to add the transport and the storage. Transport, if you are optimistic and you are actually close to a hub, if you are close to a hub, it will be $5 to $30 per ton. If you're far, it can be way more than that. And storage costs are between 10 and 50, but let's say 10, 20, 30 is probably the more realistic number. And then when you add all this up, then you probably end up, well, I didn't make the sum, but you are at, let's say, 10, 30, let's say $40 per ton to more than 200. It's a huge variation. And that you compare to the carbon price. Now, in the EU, as of April 24, the carbon price was at 65 euro per ton. So it means that a few facilities, if you are, let's say, at the right place in the right industry, can be viable today. Now, the good news is that every single, well, the overwhelming majority of financial analysts, they will tell you, yes, but the carbon price will be at $140 per ton by euro per ton by 2030. And 140 euro per ton, it's sufficient for many carbon capture projects. So that's the good news. And again, it depends on where you are because that's Europe. And if you are in the US, for example, that's different. The US doesn't have a carbon market except in a few states like California. Instead, they give incentives and they tell you for every ton of carbon you capture, we are willing to pay, let's say, $85 per ton for your project. And so again, it's a different type of incentive, but you can make it viable in many cases.
Okay. So correct me if I'm wrong. So from what I understand is you just don't collect the CO2 and just put it in the ground. You have to basically process it. You have to make sure that it's clean enough to be transported and put in the ground to make sure that it stays there for at least 100 years or so. Um, and all these things have a cost to it. So the cost will vary from project to project a lot. And so yeah, it really depends on the facility, right?
Absolutely.
Uh, so another question that I had, we already talked about it, about small industries. Now clearly, based on these numbers, scale is of importance. Um, Now, let's say a number of small industries in an industrial park, they they get together and they decide to invest in a CCUS project. Um, so in effect, they're acting as a large company. Um, but what happens if one or few of the companies pull out? So the whole thing collapses, or there are some regulatory checks and balances right now are being developed to at least protect some of them. that still
Well,
want to continue?
yeah, it's a market economy, at least in Europe. So yes, if you have some actors within a hub, we call them CCUS hubs. So they come together, they sign a memorandum of understanding, and if maybe one or two or three pull out in the middle because they see, oh, for me it's not bankable, yes, it slows down the whole process. Because, well, I don't know the specifics of the contract, obviously, that they have signed, but it means that, for example, the storage operator, to make his project viable, will need to find maybe another one who is going to join the project, right? So it doesn't mean that the project collapses, because, of course, everybody looks for solutions, but it makes it more difficult, and there can be delays, and this is why it's so hard. And this is also why they are all asking for government support.
Okay. All right. So I'm getting into the last phase. So we are almost at an hour now of our event. So I'll get into the last phase, and I'm now more focused on Carbonway and companies like Carbonway. So what is your unique selling point here? Like, because here I see it's about the big companies or the emitters or the big project builders. So how do companies like Carbonway are making a difference here?
Yeah. So if you are a small or medium company and you say, okay, I believe your presentation, we have to do something, let's do something, right? Then what are you going to do? You need to try to understand how you are going to capture and so forth. So you're going to talk to technology providers, you are going to do maybe get some grant application to get government money, and you are going to do the engineering for the project development for your integration and so forth. The thing is that currently, as per understanding, there are none, or let's say very few companies which can be independent and help those small to medium emitters develop their project. So imagine, for example, right now we have solar developers everywhere, independent solar developers and independent power providers. And our vision is that by 2030, because there will be normally so many more projects, so 2035, there will also be independent carbon capture developers, right? And this is where Carbonway wants to be. So we are going to collaborate hand in hand with those small to medium emitters to whatever part they feel unable to do themselves. If they want to share and we do half-half, or we collaborate together, that's also fine. But we do everything that they need us to do to be able to make it a reality. And the technology providers, of course, they can also do that, but they are going to try to sell you their own technology. So that is a key difference. We're independent, so we can actually compare the different technologies and advise the emitter on what is the most suitable.
So because you are involved yourself in this space, I'm assuming you see great potential for newer companies also coming up in this space and playing an active role.
There are already a lot of companies, and yes, I believe there is potential in the future. Absolutely, there's a huge potential there. What we don't know, of course, is how the whole landscape is going to evolve. Because, for example, on the technology front, we know that there are great technologies currently in development, but there is also like a huge number of startups, like 600 or something startups about carbon capture, not necessarily all for industry. But the landscape is huge, okay? And we just time will tell what will work, what will not work. Most likely, there will be a much more diverse landscape in CCUS in the 2030s than there is currently. Currently, it's dominated by large companies. Our understanding is that by in the 2030s, there will be both large companies with, of course, the large projects and a multitude of smaller companies playing their role in the supply chain. And another interesting point here is that we already see that the supply chain for carbon capture is becoming more and more segmented. So the very first project, when they announced development, there would be maybe one party or one consortium pulling the entire supply chain. Because if you develop storage and you don't develop the capture, it doesn't make sense, right? But because it becomes, there are more and more projects and more actors, it becomes more and more segmented with some companies we talk to who even answer us, well, we are not even sure about our strategy right now because it's shifting so quickly that we don't know yet whether they're going to sell only the storage or maybe the storage and transport, or only the transport, or maybe even the capture ourselves. So there is a huge potential for somebody with innovative ideas to come up and find its place in the field, definitely.
Okay, great to hear that. So I wanted to end our discussion with a slightly controversial topic. So while it is clear that we do need carbon capture, and while many big reputable organizations like IEA are completely supporting it, I also understand a lot of organizations, they do not like it. And you talked about greenwashing earlier. In the utilization part specifically, you are always running into the risk of double counting and counting certain carbon capture as uh, as an environmental measure rather than it would have been done anyway. So how do you ensure that these kind of malpractices actually stop? Are there sufficient regulatory measures in place right now, or what is your opinion on that?
All right. Okay, let me go to it's a very interesting topic to the last slide. Um, I don't know about the regulatory part. What I do know is that I totally agree with you that greenwashing is really a big issue. And I think it's more a question of um, starting a project, a CCS project, with a positive mindset. If you start your CCS project because you think, okay, the government forces me to, or okay, I'm just going to make more money with a, I mean, if the mindset is not good, you don't understand why you're doing the CCS project, it's not going to work. But if you do the CCS project and you do it because you are convinced yourself that you are going to decarbonize, you are not going to make those easy mistakes. You are not going to do like excessive marketing claims. You are going to make sure that you have some reputable company assisting you and maybe certifying it depending on where you are. And you are going to make sure that CCUS is not like a blanket solution, but only part of the solution for full decarbonization, that you've only done it for the last part that you really cannot do differently. And you have, after you have done energy efficiency, after you have changed your fuel, you are going, as you said yourself rightly, to pay attention that there's no double counting. And another important point is like, especially for utilization, you have to imagine that if you store CO2 in a green fuel and you burn your green fuel, the CO2 goes back into the atmosphere, right? So it's only green because you produced it with CO2 from another source. But it doesn't prevent the emission once you burn it. And so if you are going to do utilization or storage, try to prefer, if you can, if it's bankable, projects where you can sequester the CO2 for a long duration. In a green fuel, the sequestration duration is only a few months until you burn it. In, for example, building materials, you can keep it for decades or centuries until it's degraded. So of course it will eventually go back in the atmosphere, but for a very long time it's going to be inside. So that's much better. And that's why also geological storage is so good. It stays there for centuries.
Okay, so basically it's not all the same. We should really
No,
know what we are doing with our CO2. So,
absolutely. It's not just I do carbon capture, that's it. It's no, I do carbon capture as I part of full decarbonization and I know what is going to happen with my carbon.
okay. So thank you very much, Nicholas. I was in favor of CCUS. You have convinced me more in that direction. I learned quite a bit today from this conversation as well. And I think the main message to everybody is, um, when you see a piece of news on CCUS, or you see a claim, do verify it, do try to understand the nuances. Where is the CO2 coming from? Where is it going? What would have had happened otherwise if not for the project, before making an opinion on the project. And it should be differentiated from project to project as well. With this, probably I'll leave it to Nicholas for any last words on this episode.
Well, thank you again, Avi, for having me today. It was a very interesting conversation. As you probably noticed, it's a topic that I'm quite passionate about. And yeah, maybe a little bit off topic. It's not about CCUS, but when we talk about climate change, that's more my personal belief. It's also about reducing consumption rather than reducing emissions. So maybe by I'm trying to share this little piece of wisdom in case it can change somebody's mind. So yeah, again, thank you very much.
So what Nicholas just talked about was he touched upon degrowth. It's probably a topic of like a separate conversation completely. So maybe we will come back to you with another episode sometime on degrowth when it's the right time, because there
Sure,
are
with pleasure.
there's strong opinions on both sides and on that topic as well. So with that, let's take say goodbye, and we'll